Hello, I'm Dr. Harper. This video is an Operations Management AMBA, one-year MBA, 6270, Section 533, Spring 2021. This video is a homework video. Homework number one. By now, I hope everyone has tried it, has worked through the problems, and before you submit it, we're a team, and I'll work through these. I won't work them all the way through, but I'll show you how to set them up, how to work them in Excel, and I come to the very final and say, I'll let you do the last click, but I'll show you how to set them up and how to solve them. And so that then you can see what you've done, see what I've done, and hopefully this will help. So let's bring up the homework. Now in the homework, I start with the break-even analysis here. A local company is considering 3 options in meeting demand. Well, before I do this, let's go to syllabus. Let's go to Canvas. And notice in Canvas down here, I want to encourage everyone to go to the website, mdharper.com, under the Operations Management tab, and come down here under the first video here in the break-even analysis here. This is an Excel spreadsheet. Both of these are questions 1 and 2 in the homework. And down here in the forecasting, sometimes I say like, I think number 11 for forecasting problems with Excel or forecast accuracy. No, wait a minute. I have one. Anyway, I'll say which video to look at. Like video 1 is for I think question 3. But sometimes I'll direct you to one of these videos that applies to that question. The decomposition blocking, video number 13 in decomposition, this Excel, that's going to be the last problem actually. So I will show you how to work some of these. So there's a lot of videos here. You don't have to look at all of them. You probably shouldn't. Well, you could if you wanted to. But anyway, all these videos are all different perspectives of how to for forecasting. So I encourage you to look at some of these videos like regression here, moving average part 1 and part 2, which I did in class, the introduction I did in class, etc. Okay. So now let's come back to here. In forecasting here, I have the lectures here and the homework, and this is the homework I'm going to be going over. And this video will be posted right here. And also in this worksheet, I'll be using this worksheet also, the Excel worksheet, and just show you how to work off of the worksheet. Okay, now let's bring in the homework. As I say, the first question here, first 2 questions are going to be break-even analysis. A local company is considering 3 options in meeting demand. Option 1 requires no fixed cost and purchases the product from the supplier for $1. The other options consist of producing the product in-house at a reduced variable cost. Option 2 has a fixed cost of $300, but a reduced variable cost of 60 cents. Option 3 has a higher annual cost of $950, but a variable cost of 10 cents for each product. If you spend more up front, you can make it in the back side. Okay, for a demand of 100, option 1 has the lowest cost at $100. For a demand of 2,000, option 3 has the lowest cost of $11.50. How many statements are true? Now I gave you this header information just to make sure you have the equations right. Okay, and I would suggest using Excel. So if I bring in Excel here, and we can use these same setups here, except we have 3 options instead of 2, so we'll expand it. Now, what I'm going to be doing to keep this and not really lose it, I'll come down to the spreadsheet here. I'll hold down the control, left click and drag it, and I'll copy it to the next spreadsheet. So now I have 2 spreadsheets that are the same. Now this one is going to be our break even. So first let me erase problems 2 and 3, highlight those. So I'm going to highlight these and drag, Alt ED deletes whatever you've highlighted. So now we have option 1, option 2, and now we're going to have an option 3. Okay, and we'll eliminate these. We'll eliminate all of these. Okay, and then let's bring this down and let's see what we have here. Option 1 is no fixed cost, so that's 0, with a variable cost of 1. Option 2 has a fixed cost of 300 with a variable cost of 60 cents, 0.6. And then option 3 here has a annual cost of $950 with a variable cost of 10 cents. And there we go. And there we have it. And so, and notice I say for demand of 100 and 2,000. So let's put that up here. Let's put 100 here and 2,000. So if I do that, which I did this in class, that's equal to fixed cost plus the variable cost times the demand here, F4. We'll fix it and then copy that down. And erase the ones we don't need. And there's the values. Also, for the second one, equals the fixed cost plus the variable cost times 2,000, F4, to freeze it, and then copy that down. Okay, and delete the ones we don't want. And notice the minimum cost here is going to be 100. And let's box that in. And the minimum cost here is $11.50. And let's see, is that what I said? Yes, 100 here. Oh, where's it at? Where'd it go? Went away. Hello. Bring this down. Bring this up. There we go. Bring this down. There we go. So, for option 1 for $100, and there it is. Option 3, $11.50, and there it is. Okay. So I do this to make sure you have it set up. Okay. But then I say how many statements are true. Option 1 has the lowest cost for 700, 2 for 800, 2 for 900, 3 for 1,000. So how do you do that? 7, 8, 9, 1,000. Well, what you would do is simply just say, put 7, 8, 9, 1,000 in there. And just put it in there and see which one's the lowest. So that's how you would work it. I'll let you do that, though, now that we've set it up. Okay, question 2. A company is examining the cost of producing an item in-house rather than purchasing it from a third-party supplier for $79.50. In-house production would require a one-time purchase of equipment of $22,079, but the in-house production would cost only $250 per item. The demand for an item is a constant 10 items per week, where 1 year is 52 weeks. Okay, how many statements are correct? Whoops, how many statements are correct? Well, first of all, so on this one, there are 4 statements, and so you have to work 4 different problems once you have it set up. And then say, okay, what's the break-even after 1 week? What's the savings after 3 weeks? Well, after 1 week, what's the cost? After 3 weeks, what's the cost? After 1 year, what's the cost? And what's the savings? Okay, so we want the break-even and then these down here. But notice the break-even is in weeks. And we're going to have, when you calculate this, the break-even is going to be in items, but you have to transform the items to weeks. Well, there's 10 items per week. Okay, well, down here it's 1 year. Well, 1 year is 52 weeks. So let's bring up Excel again. And if we want to keep this, then I can copy this over again. Make another copy. Okay, now this time, bringing this down, let's see here. There's only 2. Option 1 is 0 with this is going to be 79. I'm sorry. Let's see, in-house, third party, $79.50. And in-house is $2,079 fixed cost with a variable cost of $2.50 for each one of them. Okay, and then we don't need this, so I highlight that, Alt-ED to. If you want to format this automatically, you highlight it and then double-click here, and it'll format it. Okay, so now we have these 2 things going on. And now the thing of it is what's the break-even? Okay, well, the break-even is going to be right here. And if you recall, let me come back here. If you recall the break-even, I'll do it on this one, equals parenthesis this minus this divided by this minus this. Okay, and there's your break-even. So you do that same operation on this right here. I'll let you do that. So this minus this divided by this minus this, and that's how you do it. Now over here we have 100 and 2,000, and so here what you would do, see that's going to be a 0 there. Let's see here, is you're going to put after 1 week, 3 weeks, 1 year. Okay, I want weeks here. Let me do this over here. 1 week, 3 weeks, 52 weeks. Isn't that what was said? Yeah. 1 week, 3 weeks, 1 year, 52 weeks. Okay, let's open this up again. So these are in the weeks. So then what's my demand down here? Well, 1 week is 10. 3 weeks is 30 demand. And 52 weeks is 520. Whoops. 520. Okay, so that's what you put in here to see what these costs are here and here. I'll let you do that. You do the same thing here with these to get the cost, and then you take the difference down here. Whoops, DFFERENCE. You take the difference, and then when you come back and see what the differences are, because I come down here and say, let's see, the savings of the outsource over the in-house is 1925. Okay, which means the outsource is cheaper. Okay, the savings of the in-house over outsource, it's just the other way around. So you got to be careful that you do these. You look at one is lower than the other for the savings. Anyway, that's enough of that. That's how that's done. So let's go on. Now we go to forecasting. Now this is a scenario. Amy, Bob, Edna, and Frank work for a company that contracts all their business at the beginning of each fiscal year, so the demand time series will be stationary within each year. Stationary within a year. Boom, 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 boom. Although their company has seen growth from year to year, problems with their forecasts have been increasing every year over the past 4 years, beginning with year 1 in the table below. So whatever those problems were, don't know. But Glenda, head of the forecasting committee, has called a meeting to discuss quarterly forecasts for next year. Before the meeting, Glenda collected and distributed the following data of past sales and requested each member of the committee to analyze the time series and bring suggestions for the next year's quarterly forecast to the meeting. Okay, Glenda calls the meeting to order and asks each committee member for their suggestions. Okay, Amy reported using a random component to keep it simple and not to change the procedure of using a 3-point moving average from previous years. Now notice what I'm doing here. I'm saying Amy is coming on board, and what she is saying is a good reason why you would use a moving average. 1, keep it simple. Okay, it's relatively stationary, then keep it simple. It's a random component. If that's what it is, that's simple. It's as simple as you can do, almost as simple as you can do. And then not to change it from previous years. So previous years we've done it that way, but I think what happens is they're growing now and they're wondering, are we doing this or doing it right? Glenda reminds Amy that using a moving average that assumes only a random component results in only one forecast value, which would be for the first quarter of year 5. Amy agrees, but recalls that the forecast for quarter 1 of year 5 would be the forecasts for every quarter into the future until they observe more data throughout the year. In other words, that one forecast estimates the stationary mean. Glenda then asks Amy for her forecasts for quarters 1, 2, 3, 4 for year 5 based on the random component. Okay, so we'll do that in a minute. Bob argues that the seasonal and random component should be considered. Okay, now seasonal and random components, that's Bob, argues that that should be considered. Glenda asks Bob for his forecasts for 4 quarters of year 5. Edna suggests random and linear trend components. Aha, random and linear trend. Okay, there's no seasonality, it's just regression. That's all there is. And Glenda asks Edna for her forecast. Frank proposes random, seasonal, and linear trend. Okay, now we have 3 components. So we have 1 component, 2 and 2 and 3. 1 component, 2 and 2 and 3. Okay, seasonal and random, linear trend and random, trend, seasonal and random. That's 3. And then just random. Okay, so let's work this. Now notice what I'm saying here though. And notice what the question says. From the table, select the correct set of forecasts based on each person's assumptions and approach. Amy reported forecast set. Which one of these forecasts did Amy report based on her assumptions and her approach? A moving average with a window of 3. So I'm not asking for the forecast. I'm asking for what they did for the forecast. So some people get mixed up and says, well, the forecast really is this. They're not asking that. They're saying, what is Amy's forecast? What's Bob's forecast? What's Edna's forecast? What's Frank's forecast? So let's do it. I'll set it up. I won't do it for you. So let's copy this. Let's left click and drag. Let's get this data right here. Control C. Let's bring Excel back. Okay. And then let's see here. Let's just open another window. Come down here a ways and Control V, paste it, and there it is. Okay, and so that's how you do it in Excel. Now remember, for year 5 here, we want Amy, Amy, and then Bob, and then Edna, and then Frank. Okay, and if you recall, Amy, let's see, where are we here? Amy wants a moving average with a window of 3. Good. Okay. Now Bob down here, he wants a seasonal and random, so he wants a seasonal index. The seasonal index approach. That's what he's doing. Good. Edna wants regression. Since she is only assuming seasonal and random and linear trend, then the technique of preference is regression. Okay, and then Frank down here is seasonal, random, seasonal, and linear trend. So this is seasonal index plus regression together. Okay, so that's what we're doing. So notice what we're doing here. That's what Amy, Bob, Ed, and Frank assumed. So what's going to be the forecast, the forecast for each one of these people, okay, based on their assumptions and approach, which are those techniques. So this question is saying, okay, there's your data. Now use these 4 techniques to get the 4 forecasts here. Well, let me show you how to do it. Okay. First of all, Amy here is the MA3. Well, that's going to be the average, because the average is a mean, of the last 3 data points in the time series. Well, we have year 1, year 2, year 3, year 4. What's the last 3 data points? Well, it's going to be these 3 right here. A lot of people make a mistake, say, oh, well, let's see. No, it's going to be these last 3 right here, or these 4, because that's what, no. These are not the last 3 data points. These are the first quarter of the last 3 years, and they're separated by 3 quarters. So the last 3 data points are going to be these. And so once I do that, press return. I'm not going to do it. I don't want to steal your thunder. I'll let you do it. And so let me just erase this and say return. So that's going to be my answer. Oh, well, that's going to be your answer. But once you have that, you equal this and copy that over each time. That's not a 0, but once you take the average, then that's going to be your forecast. It's the same forecast every time, because that's estimating the stationary mean. Now, Bob is seasonal indexes. Okay, when there's seasonal indexes, seasonality, that's when you block it. It's already blocked. So right here, I'm going to equal average. But this time, I do average all the quarters, because all the seasonal contribution on each one of those quarters is the same. Okay, so boom, there it is. Press return, and I'll have the forecast for quarter 1 of year 5. I'm not going to do it. Don't want to steal your thunder, let you do it. But once you have that average, then you copy it over. And that's going to be the forecast for all 4 of them. Now, Edna says regression. Aha. Now, regression says I'm looking at all of the data in a time series. Well, this is blocked. So we have to unblock it. Okay? And here's where a little bit of Excel comes in. And so this video show you a few tricks. Okay? First of all, I'm going to highlight it. In other words, I have it blocked. I need to change this to make a vector, a column vector of a single time series. So Control C, copy. Okay, I'm going to come over here, click, right click, but this time on the paste options, I'm going to come over here and transpose. I'm going to transpose it. Boom. So now 1350, 990, 720, 540 is 1350, 990, 720, 540. In other words, I've just transposed it. I just transposed it across the diagonal. So that's transposition. Okay, now that I have it, that's not what I want. Okay, now that I have this, it's not what I want. But it's in a form to get what I want. Okay, in other words, here's 4, 8, 12. There's going to be 16 of these things. So let me just put an index here. 1 equals 1 plus this. And then copy this down to 16, all the way down to 16. Hello, hello, hello. There it is. I did. Oh, whoa. That's pretty good. Right there. I did it. 16. So this is what I want. Let's center these. Here we go. Okay. Now what I want to do is take these and put them down here, these below that, but there's an easy way to do it. Just say equal this, and then copy this to here and here. Notice this is here and this is here. All I have to do now is copy this down to 16. And this will bring this down to here, then this will bring next, that'll bring next. You can sit there and logically figure it out. Anyway, there is my vector, column vector for the my time series. Okay, so now simply all I simply do is for time period 17, 18, 19, and 20. So that's the next 4. That's my forecast for the next 4 time periods. Correct? Let me box that in. That's going to be my answer. Yes, it is. But I need the intercept and slope. Yes, I do. Okay, let me put it right here. Equal intercept of, let's reduce this down a little bit, of the y's, 1 through all the way up here to 1, comma, all the x's, let me back up here. Let me do this again. That's going to equal the y's. Let me just highlight this. And there's all my y's. But before I go on, let me F4. I forgot to F4 and fix it because I want that intercept the same for each one of these. Comma, do the same for the independent variable. F4 to fix that. And there we have it. Now we plus the slope, S-L-O-P-E. Same thing. We take all of these. There they are. F4, comma, and all of the independent variables. Those are dependent. Here's the independent. F4. Now I want to times 17. I don't want to fix that because when I copy this down, I want it to be 17, 18, 19, and 20. Okay, so that's how you do it. Oh, let me move over here. There's what it looks like. There you go. This is I-20 is 17. These others are fixed. I press return. I'll have the forecast in that cell. I put it over here. Okay, let's see here. Actually, I should have put it over there. Press return. I'm not going to do it. I'll let you do that because I don't want to. I want you to experience the thrill of the answer. Then once you have it, then you just copy it down. And boom, there's your answers. Then up here, we'll just up here, this is going to equal this, equal this, equal this, equal this, and there they are. And that's Edna's answers. Good job, Edna. Way to go, Edna. Okay. Frank. Oh, seasonal index and regression. Okay, let's back up here. Let's make it a little bigger. Okay, okay, here, let's just take this over here, 1, 2, 3, 4, get these numbers. So now we block it because it's the seasonal index, we block it. When it's seasonal, you block it. Now the regression, this is not an average like Bob. This is going to be a regression. That's what Frank is saying, because there's a linear trend. Okay, so we've blocked it to have all the seasonal contributions in the very same time period together in the column. So now we'll do the regression. So that forecast is going to equal intercept of this right here. Now that's going to change for quarters 2, 3, 4, so I'm not going to fix it, comma, but I am going to fix the independent variables. See, that's going to stay the same. That's for the intercept. Plus the slope, whoops, make that a plus the slope of the same numbers, F4 to fix it, times, and that's going to be year 5. Boom. And there it is. And that's going to be the forecast. That's the forecast for that time period right there. Quarter 1 of year 5. Again, so once I press return, that's my forecast. I'll back up here, return, and then I'll just copy that over. Boom, 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 boom. And there's Frank's forecast. So that's how you get all those forecasts. Okay. And so this part of this question is just understanding the definitions of, well, understanding the question. 2, understand the definitions of these things. 3, understand how to get the answer, how to know which numbers to manipulate or to calculate. And then next is how to use Excel to get the answers. So hope this helps. Let's go to the next one. Oh, question 7. A plot of the quarterly time series for the last 4 years was given to the committee. Boom, boom, boom. Oh, okay. Well, we could have done that too. Since we're here, I mean, I could have taken this right here and then say insert plot up here. And there they are. Bing, 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 bing. This is a stacked plot. We'll do the stacked plot here in just a second. I'll show you what that means. I could have done this. And then done this. And that would be a line plot. There it is. Ding, ding, ding. And that's pretty much what they did there. Or that's what I did. Okay. Although not a member of the committee, Roger requested to be present and interjected his suggestions. After looking at the plot, ding, 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 Roger addresses Frank. The plot of the data indicates a decrease within each year from quarter 1 to quarter 4. Well, he's right. That's going down, that's going down, that's a that's trend. Therefore, the time series has a negative linear trend. Well, it does within each year. And future forecasts will continue to go down. Well, no, they're going up. But within the year, they're going down. He's right, but the forecasts are going up. Okay? I think we have a problem with future demand. Well, if demand's going down, that means our business is in trouble. How many statements are correct? Well, then you look at these statements here and you say, are 0 correct, 1 correct, 2, 3, 4, whatever. So pick which ones are right. A correct response from Frank and Glenda to Roger for this time series. And by the way, they're usually pretty polite. Be careful what you say because people can know very, very quickly. Okay, 8 and 9. Okay, a company has historically used monthly sales for 1 month as the forecast for the next month. an MA1, or that's called a naive forecast for a stationary time series. So a moving average of the window of 1 simply says, like month 1 here, that 523 is the time series. Well, MA1 or the naive forecast says that's my forecast for the next time period. That's what the naive forecast or an MA1 means. The company has been satisfied with this approach, except for the unstable behavior of the forecasts. Janine, the new MBA member of the forecasting committee, suggests using more data to stabilize the forecasts, but the committee expressed concern about placing too much reliance on past months. So that's a very good sentence. Janine says, stabilize the forecast using more data to stabilize the forecast. Okay? Well, MA1, when you use more data and increase the window of a moving average, what do? As we said in class, you're going to dampen it. You're going to stabilize. The larger the window, the enhanced noise dampening, and you're going to stabilize your forecast. So that's exactly what Janine saw. But this is how she said it. Use more data to stabilize your forecast. That's the result of it. She could have said, use a larger window to dampen the noise. Well, these people may not know what that means. So that's correct. But this statement is correct too. And that's the beauty of business. Say things that people will understand, and they can move on and make decisions from it. But the committee expressed concern about placing too much reliance on past months. Well, that's true. That's true too. I don't want to forecast tomorrow based on what happened 10 years ago. Okay, I want to forecast tomorrow based on a trend that I've seen yesterday, the last 2 days, 3 days. But I don't want to go too far back. So Janine then suggests exponential smoothing so that the weight of past data can be balanced with the stability of the forecasts. And she explains it. In other words, as you go further back in time, the weight gets less and less and less and less and less, and you balance that weight as you go back in time with stabilizing your forecasts. Well, the committee unanimously agreed. I think they believed in Janine because she was convincing in her communications with a proposal and decided on an initial smoothing parameter of 0.25. I think Janine suggested that. And they go, yeah, sure, fine, do that. Janine, and notice it's low. Remember I said usually you start 0.1, 0.2, 0.3, somewhere down there. So she started for relative low. Janine collected the time series here. Okay, and so first of all, what did she find as her forecast for month 21? Okay, again, let's do this. Let's take this here. Control C. Okay, this will even be more fun. Let's bring back Excel. Open a spreadsheet. Come down here. Just right there. Boom. There it is. Okay, and let's just make sure this is Arial. I like Arial. Little Mermaid, and then 10. Okay, now I want to take this. Control C, and I want to create a vector. A column vector. Right click, transpose. And there it is. But then I have to bring these down over here. So now I have a column. Okay. I don't need all these boxes. Let me just no border. That's better. That's cleaner. Okay. So now what I want to do is do exponential smoothing. But I want a 0.25 as my smoothing constant parameter. Equals this. Let me just copy this down then. That's easy enough to do. Boom, 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 boom. There we go. So now, here's going to be my exponential smoothing with an alpha of 0.1. Well, let me just say exponential smoothing. Okay, remember how we did this? This, in the second time period, second month, it's going to be the value in the first time period equals that value there. Okay. Now the second time period, it's going to equal the time series D times alpha plus the forecast times open parenthesis 1 minus the alpha. Okay, and so press return, and there it is. Now I can copy this down. I'm going to only come to 10. Now you're going to copy it all the way down to here, because that cell right there, that's the forecast. That's what the question is asking, right? The question is asking, what did she find as her forecast for month 21? Well, month 21 is right here. That's going to be the answer to that question. But then you're going to bring this all the way down and then see what the answer is. I'll let you do that. You're welcome. Okay, but then let's look at the next question, though. Look at the next question. Before Janine reported her results to the committee, she wanted to include a comparison of the current time series of forecasts with 0.25 with more stable time series of forecast using a different smoothing constant for exponential smoothing. Which would result in a more stable forecast? Increase the smoothing constant or decrease the smoothing constant? Well, you can figure it out, but I would suggest a better way to do that is simply say, okay, let me start right here and let me do all of it down to 21. Let me plot it. Insert chart down here, and then let's just plot it. And there it is. Okay, well, it's kind of scrunched up there, isn't it? So over here's the x's, that's the 2 through 10, and then here's my the series blue is going to be the time series. Series 2 is going to be the orange is the forecast. So I tell you what, let's do. Let's bring this down to over here. Let's make this go from 400 to 600. So you double click the axis here. Oh, and it opens up. And so over here, this right over here, and the axis options, the minimum is 400, and the maximum, make that 600. And there we go. Oh, I could even go 440. That's good enough. Now the reason I'm doing that is because this is all hardwired because now I can change this 0.25, and then it'll plot it. It'll change the plot. Okay. Well, let's see what the question says. It says, Janine, she wanted to include a comparison of the current time series of forecast with a more stable time series of forecasts using different smoothing constant for exponential smoothing. Okay, so I'm going to let you figure this out. All you do is change this. If I decrease it, let's go from 0.25 to 0.01. Let's see what happens to our time series. To our forecast. Boom. Let me change that to 0.99. What happens? There it is. I'll let you answer the question then. So that's one went down, one went up from 0.25. I'll let you answer the question from that. Okay. Good. Okay, question 10. Okay, now question 10. This question is the basis for the memo. Okay, and so at the end of their fiscal year, a consulting company wants to a quarterly forecast for the number of contracts next year. In their forecasting analysis, they examined the quarterly number of contracts over the past 3 years. Okay, here's year 1, year 2, year 3, quarter 1, 2, 3, 4 of year 1, 1, 2, 3, 4 of year 2, quarter 1, 2, 3, 4 of year 3, and there's the contracts over the past 4 years, past 3 years. Okay, 12 quarters. Okay, and then notice how I say this. If you were working for my consulting company, what would I accept as the best quarterly forecast for each quarter of year 4? So each quarter is going to be 4 of them. A, B, C, or D. Which one is it? Okay. So I'm not going to work this out, but I will work it out in the memo. But hey, let's do it. Oh, let me set it up for you. Again, let's highlight this. And notice it doesn't say what the components are. All it says is what's the best quarterly forecast. That's all it asks. So this is really the only real question in this homework, because this is the questions you'll be asked. Give me the correct forecast. Give me the best forecast of this data set. So they're not going to say, assume this, assume that. You have to assume that, okay? So what do we assume? So let's do it. Let's do a session here. So let me take these, Control C, bring Excel back, open the spreadsheet, come down here a ways, Control V, paste this, and there it is. Okay. And let's enlarge this. Actually, let's bring it back down to Arial and 10. Okay. There we go. Okay, now this is contracts per year, so let's block it. Well, first let's plot it. So let's take this right here, Control C, and come down here and paste it again. But this time, let's bring this down and let's have 1 equals 1 plus this. Let's do a line plot. Okay, let's do a line plot. So we take this line plot, let's do this. Line plot right here. This is a quarter. The quarter and the contracts. Come up here and let's see if it's going to do it. Let's see here. Up, yep, it does. So contracts here. See, here's 1 through 12. Okay, well that certainly looks like a linear trend to me. So you plot it, remember? You plot it. You look at it. That's a linear trend. We have a linear trend here. That's one component. Okay? But since it's quarterly, I know that you know that it could be quarterly. Okay? So the way to tell that is take this again, copy it, and then come down here a ways and put it right here, paste it there, and there it is. Now let's block it. Let's bring this down to here. Let's bring this down to here. Okay? And this is years 1, 2, 3, and 4. So let's take this right here, quarter 1, 2, 3, 4, insert, let's plot it with the same plot. There we go. This is a stacked plot where series 1 is year 1, series 2 is year 2, series 3, the gray, is year 3, and sure enough, every year we have a pattern that repeats. So it goes down, up, and up a little bit, down, up, and up a little bit, down, up, and up a little bit. So we have the stack plot illustrates the same pattern every year. Since the pattern repeats every year, that's a seasonal component. So now I know I have a linear trend and I have a seasonal. Also from the stack, notice that for the first year, the second year, it's the same pattern, but it's higher. And that's why you have a trend. So as this goes up as a trend, the pattern is the seasonality. Okay, so now I know what I have. Okay. Okay, so now that I have linear trend and seasonality, what's my forecast? Okay, let me make this big now. There we go. So what's my forecast here for time period 4? Let me do it right here. That's going to equal, now I know that it's seasonal, so I want to block it. I know it's a trend, so now I want the regression of each of these quarters. Equals the intercept of this right here, comma this, and fix it. Plus the slope, again of these, 1, 2, 3, comma these right here, F4 to fix it, times 4. And that's going to be my forecast. Okay, I'll let you press return. And then once you press return, the answer's there, and then you just copy that over. And there it is. And so that, there it is. And that right there should be the answer to one of these or none of the above. Okay, but that's how you work the problem. And that's how you're going to work the memo. So working on this problem and seeing what I'm doing, how I'm doing it, that's exactly the procedure for the memo. And I'll work the memo with you anyway. But then we'll talk about it and what should we tell the clients then, and what should the technical memo be and what should the video be. So we'll talk about what it should be in there as a team, but then you're charged with actually doing it. Okay, well, you know, that's all I have for this homework assignment, and I hope this helps. And between now and the next time I see you over the weekend, next week, if you have any questions, I have office hours or use the Q&A. Actually, I do want to emphasize every time I'm here, I want to emphasize the Q&A. Let's see here. No one has used it yet. And so this is where I'll be looking for questions and answers. So I would recommend that, and highly recommend that you use the Q&A on each one of these weeks, because there's where I go looking for questions, and then I'll post the answers. And also you can answer each other's questions. In other words, you can put anything in here. You can upload things. You can post your Excel spreadsheet and everything. I won't do that, but I'll certainly look at what you're doing. I won't give out answers, but I'll help you understand the material. So between now and the next time I see you, I want to tell everyone, take care.